Just like we did in our last video, I'm going to begin graphing this logarithmic function by first describing the transformations, specifically the shifts, and then stating the domain range and the equation of the asymptote before switching over to my graphing calculator to get a more accurate looking sketch. So I begin by describing my transformations. The h and the k values, what we talked about in the last video, describe how my graph has been shifted. The number in the parentheses, if there is a number in parentheses, will tell you your horizontal shift, and it does the opposite of what it says. So that +1 actually moves my graph to the left 1, which is going to be the important number I need for finding my asymptote. The k value then, the number being added or subtracted not in the parentheses, will be your vertical shift. It does what it says it will do. It moves the graph down 4, but it doesn't affect where the asymptote is. Okay. My range for a logarithmic function is always -infinity to +infinity. It goes forever down and forever up. My asymptote, though, is a vertical line, normally at x equals 0, but any kind of horizontal motion will shift where that asymptote is located. Because we've already said I've moved the graph to the left 1, my asymptote is going to be x equals -1. So I'll go ahead and draw that dashed line in there, kind of like a wall stopping where my graph is going to be able to go. I can't cross or touch that asymptote. And then finally, that helps me describe my domain. My domain is going to be from -1 all the way to the right forever, so from -1 to infinity, with a parentheses because I can never touch -1. At this point, I'm going to switch over to my calculator because the only other thing I know by hand, since my base value is a number less than 1, I'll have a graph that looks something like this. It'll start close to that asymptote and then curve away from it. But because I want to be a little more accurate, I'm going to plot this or graph this on my calculator in order to find some points to plot this more accurately. And I'll show you a few ways that you could work on getting this typed into your graphing calculator. There's a few ways that we can get this logarithmic equation typed in our graphing calculator. By far the easiest way to do this is to use the log base button. Now, not all graphing calculators have this. In Y1, I've used the log base button to type this equation in exactly as it appears right here. If you do have log base, you'll be able to tell if you hit alpha and then the window button, you'll see right there, option 5 is this thing called log base. If you select that, it lets you go ahead and just type in exactly what you want in the base and in the parentheses right there. If you don't have that option, there is a way to type it in, and I've typed that in Y2 down here. It's a little more complicated, a little more involved, but it works. To do this, you're going to use the log button, which all of you guys have on the graphing calculator right there. To do this then, you would type in log, type in anything that's in your parentheses over here, so log of x minus 4, and then divide it by the log of whatever the base is here, so divided by log 5. Notice I closed off the parentheses because I only want that base in the bottom of the fraction, and then this +2 just gets typed in at the end. I've done this using something called change of base formula, which we'll take a look at in more detail at another time. But from this point, I want to look at my table first to plot some points. So go ahead and hit second table, whichever way you've had to type that in, and you'll see I have the same values in both, so these are the same equations. You see a bunch of errors. Notice that's going to be the case anytime we plug a number in 4 or less, because there was no graph over there. We said there's a vertical asymptote. Most of your points will be irrational, nasty irrational decimals, because that's just how logarithms work, but you should be able to find a couple points that are nice in there. So I've plotted the points 5, 2, on my graph, and I plotted the points 9, 3 over there. And I've noted in the previous part of this video, my graph, because my base is bigger than 1, will have this basic shape to it. Notice this graph does go downwards forever, but it never touches that asymptote, and it goes forever to the right. One thing I want to point out based on the graph itself, go ahead and hit graph. And you'll see a graph that looks almost sort of like this, but you don't see that this graph does go downwards forever. It does. This is probably the most common mistake I see people make because their calculator does not graph that part. They don't either. The reason the calculator doesn't do it is because the graph is so steep over here, it doesn't have enough resolution, enough pixels to actually graph that in there. So it's kind of a major flaw that one reason I hate graphing these on the calculator, but we need to be smart enough to know that because my graph does go downwards forever, the range goes to -infinity, I need to do more than what the calculator shows me and make sure that on my sketch, this graph does go downwards forever, getting closer and closer to that asymptote.